Alright, we're going to look at moles and grams. We already talked about moles and atoms and particles, but now we're looking at their grams, their mass, what they weigh. And go beyond that in a little bit at the end of this. Alright, so our learning target is that I can convert between the number of moles of something and the mass of that compound or element. Alright, so the question is, what if I have 35 grams of CH4, which is methane gas, comes out of cows' butts, and I want to know how many moles I have. So, in all problems, you need just 4 steps. 1, you need to find the formula mass, or the molar mass, which is what we did last time, of CH4. Reminder, to do that, we need to find how many atoms we have of each one. So we've got 1 carbon and 4 hydrogens. We're going to take those masses from the periodic table and multiply them by how many of that atom there are. So we've got, I'm going to move my face out of the way, there we go. We got 1 carbon, and its mass is about 12. 4 hydrogens, its mass is about 1, a little over for both of them. When we multiply and add them together, we get the total mass, molar mass of methane, which is 16.05 grams per mole. So that's that mass down here. We're going to need that to solve this grams to moles problem. Note, grams is mass, moles are moles. So if we have grams per mole, that means we can use that in a conversion problem to get between the two. There's our equality. So 16.05 grams of CH4 equals 1 mole. Or remember, you could flip that and make it 1 mole of CH4 equals 16.05 grams of methane. Okay, so 2, we have to write down what we have in the table. So I use a little crossbar here, we use parentheses, it's all the same thing. So if we got 35 grams of CH4 and put that in the top left, then we should know from our conversion practice in the past what has to go from up here. This is our unit. You guys should know where it's going to go. If it's going to go up on top or if it's going to go on the bottom. I'm hoping you said down the bottom because it should be. So we use that same equality and to put that grams of CH4 on the bottom, and therefore we know that's going to go with our mass. We're going from mass, grams of CH4, to moles, and there's 1 mole of CH4 is equal to 16.05 grams. Grams of CH4 cancels with grams of CH4 to get our final answer of 2.18 moles. So in most of your work you've done in the past, there's been 1 unit, just grams, just liters, just atoms. Well, not atoms, other ones. But most things up until chemistry, you've had 1 unit maybe. Now there's going to be 2 parts. It's grams of something, moles of something, atoms of something. That of something is really important. If I say, hey, go get me 50 pounds, you say, okay, it's going to be kind of tricky to know what I'm talking about. 50 pounds of lead, of gold, of pencils, of what? The of what is extremely important, especially when we get these to be longer and more complicated and they start to cancel with 3 or 4 or 5 step problems. We need to have both parts in your unit, so get good at practicing writing it down in these short 1-step problems, so the ones we do a little later on won't be so bad. Okay. Like we said, the top and bottom units cancel. Okay, so now we flipped it. If we go back 1 slide, we had 35 grams of CH4. They want us to go into moles. Now we're going from moles to grams. So it's the same idea, though. We still need the molar mass because we have grams and we have moles. So if we have both those two, we're changing between them. Then we need to convert them. We have to have that equality. The same steps we did before. Find how many atoms we have, find their atomic masses, multiply them together to get the total amount. This should be identical to what we did before. It's the same molar mass, it's the same compound. It's still CH4, still methane. We're just going to use it a little differently in this next step. So what we have in the top left of our chart, what we're starting with, we put over 1 if you want, isn't 35 grams of CH4. Now it's 35 moles of CH4. But again, that unit has to cancel, so it's got to go from moles of CH4 up here. It's got to go on the bottom so it can divide out. So moles divided by moles will go away. So use that molar mass in there. Put the moles on the bottom, the other part on top. And when we do the math here, we're going to get a much bigger number because that 1 on the bottom, which we're worried about, we're just going to multiply the moles, the 35 moles up here times grams. We get 561.75 grams of methane. A mole is a lot, so the mass is going to get bigger if you're trying to find mass usually. If you get a teeny number for grams, double check your work to make sure it's not correct, but 1 mole will get you a decent sized mass. So again, now top and bottom units still canceled. In this case, they're just moles instead of mass. Alright, if these are making sense, and you think they are, you've got good notes down on them, you can try these on your own. If so, go ahead and hit pause. And if so, you'll get this one. So there's going to be 3 problems total. If you think you get it, pause it once you see the question. I'll give you a few seconds. Try and work it out. Then watch our steps of conversion with the units up here, units down there canceling to get our answers. So in this case, you get 0.41 moles of KOH. Here's another one. If you think you get it, pause, try it on your own, then unpause and see if you're right. That's a good way of checking your understanding. Okay, so to have our units cancel again, what we're given goes on the left. That moles of MgOH2 has to cancel down here. The molar mass of MgOH2 is 58.32. So when we do the math, we end up with 245 grams of MgOH. Nope, we're rounding to 2 decimals. That's safest for my class. If you're not in my class, you may want a different number. Last one. Give this one a shot on your own if you've not done that yet. Okay, so take our unit we're given again, put it in the top left. The grams of CuCl2 are our starting unit. They have to go down here and cancel. We're going into moles. Do the math, and we'll get 0.4-ish, I'm guessing. 0.38 moles of CuCl2. Hopefully that makes sense. If not, ask some questions.